Okay, today we're going to talk about graphing polar equations. So let's start off and kind of think about what we did last time. So remember, polar graphs have a radius from some center, which they call the pole, and then have some angle. So let's look at two polar equations. If you've got a polar equation where you have, as in this first example, r just equals some numbers. So you've got just some radius, right? R equals 3. It doesn't matter what theta it takes on, right? So if you think about, hey, all of our points are r comma theta, all of these points will be 3 comma theta, okay? So if we think about this having a unit of 1s, this is like radius 1, 2, 3, we're saying in this case, hey, for example, if theta is equal to 0, we're talking about this point right here. Or if theta is pi 6, we're talking about that point, right? Or pi 4ths, if theta is 5/4, the radius is always 3. So it doesn't matter what the angle is, it will always be these points that have a radius of 3 from the center. So if you start to connect all those points, you'll notice that you just get a circle with radius 3. So that's probably kind of one of the easier ones. You get a circle with radius 3. Okay, let's think about just if you had some angle. So we've got a polar equation, we've got that it's 5 pi/4. Okay, so in this case, this time we're gonna have any radius. So it can be positive, it can be negative, but the angle will always be 5 pi/4. So let's think about what we did last time. So what we did last time is we graphed these points. So for example, if I had a radius of 1, think about, remember how we started there, and then we'd rotate all the way to 5 pi/4. So we're talking about that point there. I'm going to kind of erase that work and just end up plotting the point. We're talking about this point here. And if I had a radius of 2, same thing. You start 2 out and then rotate 5 pi/4, and we're here. Okay, let's talk for a second. What if your radius had been negative? So I did not do it this way last time, but if you started with actually no, this is how we did. We did a radius of -1, and then we rotated it 5 pi/4, and we'd end up all the way over there. So, hey, if you have negative radiuses, we'd end up at this point, or a -2 radius would end up here, a -3 radius would end up here. Now think about connecting all those points, right? You could even have a radius of 0, and we'd be at the center. If we connect these points, what do you end up with? We end up with a line with that theta value, right? We end up with a straight line. Okay, so those are kind of the two basic cases. We're going to now look at things that have both an r and a theta. So there are some different methods to graph these, but I think the easiest for us is going to be to come up with a table of values. And then if we can understand what it looks like in the Cartesian kind of quantum plane, like x and y with r and theta, then we can equivalent that to what it looks like in the polar plane. So in this first one, we are graphing r equals 2 cosine theta. So I'm going to set up a table of values. So we're going to have theta, and then we're going to have our r, which is equal to 2 cosine theta. In general, we want to put our thetas up by like pi halves. The reason we do pi halves is because think about the unit circle, each of the axes are at pi halves, so it's like a good breaking point without doing too much work. But you could count by 4ths, you could count by 6ths, right? All of that would work as well. In general, pi halves is a good default, although on your homework as well as on like the test, it actually gives you some angles to plug in to help you know what it looks like. So now we're going to plug it in. We're going to do 2 times cosine of 0. So 2 times cosine of 0 is 2 times 1, which equals 2. We're going to do the same thing with pi halves. 2 times cosine of pi halves, which is 2 times 0, which equals 0. We're going to do the same thing with pi. 2 times cosine of pi is 2 times -1, so we get a -2. We're going to do 2 times cosine of 3 pi halves, which equals 2 times 0, which equals 0. And then we're going to do 2 times cosine of 2 pi, which equals 2 times 1, which equals 2. And a lot of times here, when you get notice how there's 2 at the beginning and 2 at the end, if you continue this, you'd actually get that same pattern. 2, 0, negative 2, 0, 2, 0, negative 2, 0. Just make sure you've gotten far enough to understand that pattern. Okay, so now let's think about this graph on kind of if we call this x as our theta, and this y as our r, let's think about what that graph looks like, right? And we should know how to plot the equation y equals 2 cosine of x, right? But if you don't, we got some points here. So 0, 2, right? This is where it starts. And then we're going to have pi halves marked. We're going to have pi, 3 pi halves, and 2 pi. Okay, so then it becomes 0 at 2 pi. We should also go down to negative 2, right? And it goes up to 0 here and up to 2 here. And that's exactly what the graph of cosine looks like, but our amplitude has changed, right? Okay, so now let's think about what this looks like on our polar graph. So I'm going to kind of color coordinate things. So let's think about plotting this point. So we got a theta of 0 and a radius of 2. So a radius of 2 means we go 2 out, and we got a theta of 0. Okay, we're right there. Now let's think about the next point. So the next point is pi halves and then 0. So if we go up pi halves but have a radius of 0 right there at the center. Okay, at this stage, let's talk about what's happening with that radius, right? In general here, on this part of the graph, the radius is getting smaller and smaller. It's getting closer and closer to 0. So think about connecting that green to that blue point where the radius is getting smaller and smaller, right? It's hugging closer and closer to 0. Okay, now let's go to the next one. The next point here is at pi and then negative 2. So I usually think about going negative 2 on the left and then going pi here, which brings us back to that green point. So we're right here. And in this case, our radius is negative, and it's getting closer and closer to that negative 2. So it is negative, so it is in this bottom, and it's going like that. Okay, and just for kicks, I'm going to kind of continue on with this. If we look at this next point, which is 3 pi halves and 0, we're saying, okay, 3 pi halves, 0, and in this case, we're getting closer and closer to 0, but it's also negative, right? So we could kind of go back along this part. And then last but not least, we got 3 pi halves to 2 pi. 3 pi halves to 2 pi. And here we're going to positive 2. So positive 2 and 2 pi would go all the way to the circle back there. And it is getting closer and closer to 1. So in general here, we did the graph twice, but we end up, in this case, with a circle. And whether or not you recognize that as a circle or maybe yours is a little bit more oblong is hard to know. But in general, these things will be kind of nicely rounded. And I'll show you some kind of patterns there at the end. You could always do more points to kind of figure that out, right? Like if you plugged in pi fourths, then you could see what that is, and that may help you out, etc. Okay. So let's look at the next one. On this next one, we are looking at 3 sine of 2 theta. Okay, so let's do the same thing where we start with a table of values. So we're going to have theta, and then r equals 3 sine of 2 theta. Okay, you know how I said you always count by pi halves? In this case, since we've got a 2 theta, I would set the 2 theta equal to pi halves and solve for theta. So this time you get theta equals pi fourths. I would end up counting by pi fourths to make the graph a little bit accurate. So we know 0, we can have pi fourths, we can then have pi halves, which is 2 pi fourths, 3 pi fourths, pi, 5 pi fourths, 3 pi halves, 7 pi fourths, and 2 pi. Yes, that's probably a little extreme. You probably don't need all of that maybe to see what it is, but I think at the beginning here it's good to see it. So when we plug in 0 for theta, we're going to have 3 times sine of 2 sine of 2 times 0. So we're going to have 3 times sine of 2 times 0 is sine of 0, which is 0. So we get 0. 3 times sine of 2 times pi fourths is sine of pi halves, which is 1. So 3 times 1 is 3. I'm going to just continue on here. We're going to have 3 times sine of 2 times pi halves is just pi, and sine of pi is 0. So we're going to have 0 again. 3 times, basically 2 times 3 pi fourths is 3 pi halves. So that's going to give you a negative 1. So we get negative 3. I'm going to let you plug in these other values, but you should get 3, 0, 3, 0, negative 3, and 0. So notice how the pattern does continue. Okay, so let's think about this graph for a minute then. On this graph, we can think about the y as being your r and the x as being theta. In this case, we do want it to extend 3 up and similarly negative 3 down. And we're going to have pi fourths, and then I'm going to have pi halves, and then pi, 3 pi halves, and 2 pi. Okay, so my graph starts at 0, 0, then it goes up to 3, goes back to 0, goes down to negative 3, back to 0, and it continues, right? It repeats itself, which makes sense. Remember how this is going to change the period if you got 2 theta inside it? Okay, and let's now think about plotting these points. And this one won't necessarily repeat itself as much. So we're going to start at 0, 0, right? Right there at the pole. 0 radius, 0 theta. Then I'm going to go to pi 3. So we're going to go out 1, 2, 3, and we're going to go to pi fourths. Or you can think about it going pi fourths to 3. So this part of the graph, we're saying, hey, it's getting increasingly kind of bigger. So we're coming out to here. All right, so now let's talk about the next part of the graph. So now at pi halves, we're going back to 0. So at pi halves, we're at 0, we're back at the origin, and it's getting closer and closer to 0, so we're going to approach back to 0. Okay, now let's look at the next part. The next part, we're going to negative 3. So you can think about going left 3, but this time we're going pi 3 pi halves. So if I go to 3 pi halves, this is pi halves, pi 3 pi halves. We're talking about all the way, sorry, this is 3 pi fourths. So we're talking about, so negative 3 and then 3 pi fourths will bring you all the way over to here where 7 pi fourths is, right? So we're talking about this point now here. And we're getting closer and closer to kind of that negative 3. Now, as we look at the next part, we are going from here back to pi being 0. So we're going to kind of approach back to being 0. Okay, so now if I look at this part, from pi halves to positive 3, so technically this is 3 pi fourths, so I can think about going out 3, but then 3 pi fourths is going to bring me over here on that second quadrant. So we're getting larger and larger. Then I'm getting closer to 0 again, right? So I'm coming back in. And then this last part of the graph, I'm going to just do kind of in this purple color. So we're going negative 3, so negative 3. And then if you were to travel 7 pi fourths, you know what? I messed up that last part, just what quadrant it was in. So let me take that back for 1 second. So if we think about this turquoise part again, okay, this is 3 pi fourths, so it's gonna, sorry, this is 5 pi fourths, not 3 pi fourths, that's where I messed up. So if we go positive 1, 2, 3, and then we go pi fourths, we're over here in the third quadrant, not the second. Sorry, that was my bad. So we're over here. and we get closer to that value. And then we do come back into 0 still, right? Okay, now on this very last part, we're doing -3, so -3, but then we go all the way 7/4, so we'd end up over there, right? So we end up at this point here, and we connect it as well. So this one looks like a flower. They often call it a rose. For this one, if you kind of want the informal name, it's called a rose. Well, actually, that's the name we call it. Okay. You don't have to know the names, but sometimes I guess it may help you to recognize the patterns. Okay, let's look at this next one. Same idea. Let's have our thetas. And then let's have r equals 2 plus 2 cosine of theta. So this one we can just count by pi halves because we don't have anything in with the theta. I'm going to just plug it in. So we're going to do 2 plus 2 times cosine of 0 is 1. So we end up with 4. Then we're going to do 2 plus 2 cosine of pi halves is 0. So we end up with 2. We're going to do 2 plus 2 times cosine of pi is -1. So we end up with 0. 2 plus 2 times cosine of 3 pi halves is 0. So we end up with 2. And we're going to have 2 plus 2 times cosine of 2 pi is 1, so we're back to 4. And if you can imagine, that pattern will continue, right? So in this case, we're going to be a little bit more top heavy, right? 1, 2, 3, 4. So this is like your y. Think about graphing with y, which is going to be like your r, and this is going to be x of theta. And we've got 0. Oops, sorry. 0 should be over here. 0. Right? And then we got pi halves, pi, 3 pi halves, and 2 pi. So this graph starts at 4, and then it comes down to 2, and then to 0, and then up to 2, and up to 4. Which, if you know what cosine looks like, right, that looks like the cosine graph. In this case, you can think about it shifting up to, that's why it's all above the x-axis, right, and the amplitude is also changed, so it makes sense. Okay, so now let's plot some points and kind of equivalent that. So we're going to have a radius of 4 when theta is 0. 1, 2, 3, 4, so we're all the way on the outside. And we're going to connect that to a radius of 2 at pi halves. So these two things are being connected. Okay. And after that, for the record, I did that a little bit high. It's because I kind of know what the graph looks like, but if you just kind of connected it, you'd be able to match things out. So now we're going to connect from pi halves to pi. So at pi, we're at 0, so we're connecting here to 0. Okay, and then I'm going from 3 pi halves to 2. So if it's got a radius of 2, and I go, so radius of 2, think about going 3 pi halves, we're actually down here almost like it looks like a -2, right? So it's going to be down here. It kind of mirrors the same thing. It looks a little bit like that. Okay, and then last but not least, we are going to do this little part here, which goes from 4 as a radius, right, to 2 pi, which is actually at that same spot there. So it connects back here. And they call this one, the informal name, I would say, is like a heart, right? However, if you wanted the proper name, it's called the cardioid. Which makes sense. Cardio has to do with your heart. Okay. 2 more here. The next one, let's do theta. And let's do r equals 1 minus 2 sine of theta. So we're okay just to count by our pi halves here. Okay. So So we're going to have 1 minus 2 times sine of 0 is 0, so we get 1. 1 minus 2 times sine of pi halves is 1. So we get negative 1. We're going to do 1 minus 2 times sine of 0 is 0, so we get 1. 1 minus 2 times sine of 3 halves is negative 1, so we get 3. And we get 1 minus 2 times sine of 2 pi is also 0, so we get 1. So, as we think about this graph, right, we've got 1, 2, 3 for our r, which we're kind of equivalent to y. X is going to be like our theta, and we're down to negative 1. And then we're going to have pi halves. We're going to have pi, 3 pi halves, and we're going to have 2 pi. So here we start at 1. We go down to negative 1. We're back to 1. We're up to 3, and we're back to 1. Notice that kind of looks like sine. We did shift it, right? It's shifted up 1, and it's also like the reflected because it's negative cosine now, right? Okay, let's now think about plotting those points, etc. So we're starting at a radius of 1 when theta is 0, right? And we're going to a radius of negative 1 and then pi halves. So radius of negative 1, pi halves will actually bring me down here to the bottom, right? Okay, when you connect these, be a little careful. Notice how this first part of it is positive and then it is a negative. So we're going to start off with positive and then go negative. Okay, now we'll notice we're going from this point to pi being 1. So pi being 1 is over here. And notice we start off negative and then turn positive. So we have to stay in here. We're going to start off negative, and then we'll go positive as we approach that value. Okay, the next part here is going from to radius of 3, but then 3 pi halves. So radius of 1, 2, 3, 3 pi halves, right, is going to be down there. So we're going to connect it to here. And then last but not least, we've got 2 pi, radius of 1, so we're back to where we started. Okay. This one, we don't quite call this one as a nickname of a heart because it has that little like central curly cube. The technical name for it is a lemicon. Okay. This last but not least one, I'm going to admit it's a little bit more difficult because you got r squared. There's one on the homework like it. However, I'll be nice to you on a test or a quiz. You won't see it. So let's think about this as theta, and then r squared equals sine of 2 theta. So we can do, in this case, since I do have that sine of 2 theta, like 2 theta equals pi halves, divide both sides by 2, I would count in this case by pi fourths, otherwise you may kind of miss some things. So 0, pi fourths, pi halves, 3 pi fourths, pi, just to be safe since we're still starting off, 5 pi fourths, 3 pi halves, 7 pi fourths, and 2 pi. So, as you plug in things here, right, if you plug in for 0, you'd have sine of 0, which is still 0. As you plug in pi fourths, we'd have sine of pi fourths times 2, which is pi halves, we get 1. We get 0, we get negative 1, and after we repeat this, we get 0, 1, 0, negative 1, 0. And you could plug those in if you didn't trust me. So let's just think about it for a second here. In this case, we'd actually have this as r squared as like our y, right? This would be r squared, and then this is technically theta. So if we were talking about r squared, then we're saying, okay, we start at 0, 0, And at pi fourths, we go up to 1. And then maybe I should just actually label every pi halves. So at pi halves, okay. So at pi fourths, we go up to 1. At pi halves, we're back to 0. Can also label a -1. So we'd go down to -1. We'd come back up. And 3 pi halves, we'd be up and back down, right, all the way to our 2 pi. So, as we know, this should look like sine, but our period has changed, right? However, let's talk about it for a minute, what it means that this is r squared, right? The fact that this is r squared, can r squared ever be negative? And that's not true. So we actually can't have this bottom portion, right? We can't ever have r squared be negative. So we're going to focus just on these top parts. So if I focus on that, and I actually wanted to think about r, technically here, when I have +1, if I took the square root of r squared, I would get plus or minus. So here at pi fourths, right, I technically could be at a +1, or I could have had that approach a -1. So I technically would have both of these 2 points. And then it would have come back at pi halves to like here. So let's just think about what that looks like on the graph. So we started at 0, 0. This one on the top goes at +1, we're up at pi fourths, so we're here. And it's approaching getting larger, right? And then if I think about that same part of the top, it then takes that part and goes back to 0, 0. Or sorry, I should say pi halves. 0 as the radius, pi halves as your theta. So then let's think about this bottom portion. On this part, we're going to start at 0, 0, but we're going to -1 pi fourths, which is over here. And then we're going to come back to 0. In this case, if you do think about this other portion of the graph, right? So this part where it's going at pi, this is pi halves. At pi, where it kind of goes up, and let's just mirror this. If you actually graph these points, so like 5 pi fourths, 1, 5 pi fourths, 1. You'll actually notice if I go 1 and then go 5 pi fourths, I'm actually plotting the same part over there. So it actually just duplicate what you've already done. So that's actually your entire graph. And if you want the fancy name for it, it's a lemniscate. Okay, that gives you the instruction. You should be all set now to go ahead and do some graphing on your own. I put these down here so you can kind of see these are the different possible polar graphs that we can get. So if that helps you, you kind of can see some patterns. It also shows you the format. So depending on what your equation looks like, you'll get certain types of things, but I think that's a lot of memorizing. It's a lot easier to plug in some points. All right, good.